the orbital speed of an object and the orbital period. And there is also acceleration of an object due to gravity and gravitational force, and the mass of the object being orbited. These are the common questions that we get when dealing with planets. So first of all, let's start with orbital speed. We know the force of gravity is the force pulling the planet in toward the sun. So since centripetal force is a force that pulls an object inwards, force of gravity is equated with centripetal force. Now we can expand these equations. And centripetal force, we can use this equation in our case because we're looking for speed. And now we can isolate and do some canceling here and get this out, and then we get V equals gmr. So there's your orbital speed. So how about orbital period? We know the orbital period is t, given by the symbol t. And we also know the formula that centripetal force speed, because this is a centripetal force question, we have t here, and we have the centripetal speed here. So if we just arrange it, we can find the orbital period given this. Now, let's jump to a slightly different question. What if we are being asked for the mass of the object being orbited? So that's a good part about this equation. It can give us a lot of different things. So we are going to recycle that. Centripetal force equal to the force of gravity. The only difference with the first case is the centripetal force is going to be used with this equation. Okay, and the rest is still going to be the same. So let's just write that down. Orbital mass of the object being orbited. The orbital mass. Okay, we're looking for the mass. We can do some canceling out here, such as here and here. And if we do the isolating, what you will end up getting is the mass of the object being orbited is equal to okay. Now, I just want to point out this is a mass of the object being orbited, such as the sun, and this is the period of a satellite. Satellite is anything that's orbiting an object, such as the Earth orbiting the sun, or a satellite orbiting the Earth. Those are all satellites. So the period of a satellite and the mass of the object being orbited. That's how you find the mass of the object being orbited. So just something I want to point out, especially here, we have seen how we have orbital speed and orbital mass and all this stuff, and it looks a little complicated, got different equations going on. But in the end, you're still using this grand equation here, and then you're deriving what you need out of it by manipulating what you substitute for centripetal force. Okay, so these are the three things that you will need: orbital speed, orbital period, and orbital mass. These are the three things which you will need to equate centripetal force with gravity, because these three variables all deal with an object in centripetal motion. Now there are other planet questions, such as the acceleration of an object and the gravitational force between two objects, and those also deal with planets a lot. So we'll also take a look at those. Okay, let's start with centripetal. gravitational force. So gravitational force is a force of attraction. And it doesn't have to be the attraction between two planets. It can also be between two persons, two boats, a person and a boat, or whatever. Gravitational force, we already learned, is this, which is what we had above here, this thing. And then you can just calculate that easily, very easily. Mass 1, mass 2, and radius squared. Okay. Now, what about the gravitational acceleration? Acceleration due to gravity. We know it's like around 9.8, but what if it's a satellite in space orbiting Earth? You can easily derive that from force of gravity because we know Newton's law is mass times acceleration. We know it's mass times acceleration. And we know it's still going to be this because that's what we had here. Only this has become mass times acceleration. We cancel these things out. And we end up getting acceleration is equal to mass. And then we got this. So this is acceleration due to gravity. Your units will end up to be newtons divided by kg, but that's equivalent to this. So don't panic. Also, just something I want to point out is a mass here has to be the mass of the object being orbited, because the object being orbited is the one with a bigger gravity, and we've learned that acceleration on Earth is inversely proportional to the distance from Earth. So that means if an object is farther from Earth, the force of gravity will be less, which means the mass here should be the object being orbited, such as Earth or Sun or what have you. So now we learn how to solve for gravitational force and acceleration. And these are your generic space planet questions.